And we're back. All right. So we're going to hit 9.2 now. We're going to talk about reducing ozone depletion. So if you remember, we talked about that ozone depletion happening from the CFCs in the atmosphere. Well, how are we going to stop this? How did we stop it, really? Because it is something that has, luckily for us, become much less of a problem. So in 1987, 197 countries signed on to the Montreal Protocol. And the Montreal Protocol was an agreement that limited or banned CFCs in many countries. So the question we're going to try and get to is, what was that agreement? Well, it was the Montreal Protocol. But more importantly, was it effective? So we're going to look at some data to see if it was in fact effective. Okay, so here you go. This is the production of main ODS, ozone depleting potential tons, gases. So was it effective? If we look at these countries, so European community, United States, and Russia, and China's on there as well, did we see a significant decrease in ozone depleting potential of the ODS gases? It kind of was, if you really think about it. I mean, look at the numbers and look at the sharp drawback. Hi, Resi. So, effective chlorine and the Montreal Protocol. This is kind of a graph to give us an idea of what could have happened versus what did happen with the Montreal Protocol. So when we talk about these CFCs, we're looking at halons, HCFCs, CCl4, CH3CCl3, CFCs, CH3Br, CH3Cl. So these are all noted in this graph, and they're all broken down there. So you can see there was a sharp rise from, about 1950 through to the end of the 1980s. The Montreal Protocol went into effect in 1997, so right about here. That's when it was signed. So you can imagine that, hey, it's pretty tough to say that this is not a direct result of the Montreal Protocol. Now, predictions are that it will continue to decrease. We'd love, of course, to see this sharply decrease, but the belief is that if we had never created this protocol, we'd be seeing rates right now almost twice as much as what they were when the Montreal Protocol was initially put into place. So when we look at world ozone depleting substance consumption and ozone hole area, so we look at the area of the hole, the ODS consumption has dropped significantly. We can see that in the red. The blue is the ozone hole area. Okay, obviously these little areas where there's nothing, that just means there was no data. I think. But you can see it fluctuates. It's not going up anymore, but it has stayed pretty steady. And that's a question of, are we doing the right thing? Because it's saying steady, but it's not going back down. So we can actually see data from the ozone hole over the Antarctica from 1979 to 2010. And you can actually see in 1979, all the way down, right? This is the total amount of ozone. And we can actually see Montreal Protocol, gets put into place. It doesn't really look like it got better. It more looks like it just didn't get worse. So that's something we can actually think about. So this is a fun little tweet. You guys cried wolf about ozone depletion. So a lot of people, when they look at this data, say, see, there was no problem. Look, there's no problem in ozone depletion. Well, imagine what this graph would look like if we did not put in the Montreal Protocol. If that had not taken place, how bad could this ozone hole have gotten? So some would say that they actually saved our lives. All right. That is the end. There's an interesting article from Atmospheric Chemistry and Physics that you can look at if you really want to get nerdy, that talks about what would have happened to the ozone layer if CFCs had not been regulated. In this world avoided simulation, 17% of the globally average column ozone is destroyed by 2020, 67% by 2065. So yeah, it's tough to say that the Montreal Protocol did not work. So ozone levels in the tropical layer stratosphere remain constant until about 2053 and then collapse to near zero in 2058. Just some things to think about. That's the end of preventing ozone depletion. The next video is going to be all about the greenhouse effect.